Welcome to the deep dive. You send us your sources, we extract the essential knowledge and insights.
Think of it as your express lane to becoming well-informed.
And today, we're taking on a truly cosmic journey.
That's right. We got a fascinating request for a deep dive into, well, the cosmos itself, the origins of life, our place in it all.
And our source for this exploration is really a classic, Carl Sagan's Cosmos.
Monumental is the word for it.
Now, Sagan, he wasn't just an astronomer looking up, he was involved, really involved in reaching out there.
Yeah, director of the Lab for Planetary Studies at Cornell.
Involved in Mariner, Viking, Voyager missions. These were the missions that gave us our first proper look at other planets.
He got NASA medals for that work, for, pushing science forward and for sharing it.
And the book Cosmos itself won a Pulitzer. I mean, a real giant in the field.
Absolutely. And this deep dive, it's tailored for you, the learner. You wanted to grasp these big ideas without getting totally overwhelmed.
So our mission is to provide that clear path, hopefully with some of that Sagan wonder mixed in.
Let's do it.
Okay, let's jump right in. Page 1, the dedication. Sagan dedicates Cosmos to Andrian.
Oh, it's beautiful.
In the vastness of space and the immensity of time, it is my joy to share a planet and an epoch with Annie.
Just that sentence throws you straight into the scale of it all, doesn't it? The vastness.
It really does. And right after that, he quotes the Popol Vuh, the Mayan sacred text.
Yeah, about the first humans gaining all this knowledge, seeing everything.
And the creator almost wanting to pull back their understanding a bit.
Exactly. It's this ancient recognition that understanding the cosmos is, well, it's profound, maybe even a little scary. It's a theme that runs right through the book.
It makes you think. I mean, the sheer size of space, our brains just aren't built for it, are they? Not on that scale.
No way.
Sagan tries to help us grasp the numbers, the distances, galaxies. It just dwarfs everything else.
Right.
So the key takeaway isn't just the bigness, it's how that perspective should maybe shift how we see our own lives, our daily stuff.
Definitely. We feel central, but statistically, maybe not so much.
A fleeting moment and a huge cosmic drama.
And that vastness of space, it's mirrored by the immensity of time. Sagan takes us way back. Early Earth.
Unrecognizable, right?
Totally. Atmosphere thick with hydrogen, lightning flashing, UV radiation pouring down, bombarding simple molecules.
Like a giant, messy chemistry lab.
Exactly. Brewing something incredible.
And in the oceans, this process created the organic soup.
That's the term. A mix of more and more complex molecules.
And this is where it gets really wild.
Yeah.
Sagan describes how, just by chance, a molecule appeared that could make rough copies of itself.
The first self-replicator, like a tiny machine learning to build itself.
The ancestor of DNA.
That's it. And what's amazing is it used the other molecules floating around in the soup as its building blocks.
Wow.
And over time, this evolved into the DNA we know, the double helix.
Yet the rungs made of nucleotides.
Right. The four letters A, T, C, G. Think of them like chemical Lego bricks.
And that's the genetic code, the instructions for, well, everything alive.
Everything. The profound takeaway here is that life, all this complexity, it arose from simple chemistry, accidental replication, trial and error over enormous timescales.
Shows how seemingly impossible things can happen given enough time.
Absolutely.
And these 4 letters, this alphabet, it spells out bacteria, blue whales, everything.
All variations on the same basic code. The differences between us, between species, it's all in the sequence of those letters.
Just the order they're in.
Exactly. And Sagan really highlights mutations here. Random changes in the letters.
Which get copied down the generations.
Right. And most mutations, they're bad news, harmful, even lethal.
But occasionally.
Occasionally, a tiny change happens that's actually beneficial, just slightly better.
And that tiny, improbable event, that's the engine of evolution.
That's the engine. It drives everything forward.
So it's like this constant, messy trial and error. Inefficient copying, competition for the building blocks, the slightly better versions winning out.
That's molecular evolution in a nutshell.
Yep.
And over vast stretches of time, these molecules, they started teaming up, specializing.
Forming the first cells, like molecular collectives, he calls them.
Yeah, I like that term. He gives examples like chloroplasts in plants.
For photosynthesis, right, using sunlight.
And mitochondria in animal cells for energy.
And the really mind-blowing idea is that these things, these organelles, might have once been free-living cells themselves.
That's the theory. Endosymbiosis. It suggests our own cells are like little ancient communities.
It does make you feel like a walking ecosystem.
Doesn't it?
And then another huge leap, maybe 3 billion years ago, cells started sticking together.
Right, maybe a mutation stopped them separating after dividing. Suddenly you have the first multicellular organisms.
Sagan says every cell in your body is like a commune,
Yeah,
these once independent parts working together.
100 trillion cells making up,
Yeah.
or a multitude.
We really are. And then came sex, about 2 billion years ago. That really changed the game.
Oh, absolutely. Before sex, evolution was slow, just waiting for those random mutations to pile up.
Painfully slow, you'd imagine.
Incredibly gradual. But sex allows organisms to swap whole chunks of DNA, mix and match,
So it massively speeds up, creating new variations for natural selection to work on.
dramatically.
Yeah.
As Sagan puts it, organisms are selected to engage in sex. Those that aren't interested, well, they tend to vanish.
Hard to argue with that logic. Okay, then about 1 billion years ago, plants did something amazing. Oxygen.
A truly pivotal moment. These simple green plants filled the oceans and started pumping out molecular oxygen as waste,
And it built up, changed the whole atmosphere.
irreversibly. From hydrogen-rich to oxygen-rich.
Mm.
It actually ended the era when life's building blocks could form non-biologically.
But oxygen, that's also kind of toxic, right? For unprotected organic stuff.
Fundamentally, yes, it's a poison.
Yeah.
So this oxygen revolution was a massive crisis for a lot of early life. Many organisms just couldn't cope, wiped out.
It's strange to think the air we need to breathe was once a deadly pollutant.
It is ironic. And what's also amazing is the nitrogen, most of the rest of our air, it's also biologically maintained.
So Sagan's point is 99% of our atmosphere is made by life.
Basically, yes. The sky itself is a biological construction,
Wow, that's a perspective shift.
isn't it? Now, for most of life's history, maybe 3 billion years, it was mostly microscopic blue-green algae running the show.
Just algae for billions of years.
Then, around 600 million years ago, boom, the Cambrian explosion.
A sudden burst of diversity.
Rapid diversification, the algae's grip was broken, loads of new complex life forms appeared pretty quickly.
Sagan notes life itself seemed to start relatively quickly after Earth formed.
Which suggests maybe life arising isn't that hard on Earth-like planets.
The long wait before the Cambrian explosion, those billions of years of algae.
That suggests evolving complex, large organisms is much, much harder, a bigger hurdle.
So maybe other planets are teeming with microbes, but lacking the big beasts and vegetables, as he says.
It's a definite possibility. And even successful species don't last forever. He mentions the trilobites.
Oh yeah, those cool segmented things.
Beautifully made, dominated the oceans for ages, vanished 200 million years ago. Gone.
Earth has seen countless species come and go, leaving no trace.
Exactly. Every species alive today
Yeah.
didn't exist at some point and won't exist forever. It's transient.
Before the Cambrian, evolution seems slow, though maybe the fossil record isn't great for soft bodies.
True, preservation bias. But after the Cambrian, things definitely sped up. Fish, vertebrates, land plants, insects, amphibians,
Reptiles, dinosaurs, mammals, birds.
flowers, primates, humans. A breathtaking cascade of innovation.
Makes you feel pretty recent on the scene.
Very recent. And humbling, too, considering we still haven't managed to, create life from scratch in a lab.
No, we haven't. The simplest things, viroids, are still thousands of atoms.
And they probably came from more complex things anyway. Nature had a 4 billion year head start. That's a lot of time for trial and error.
But the basic ingredients for life, the chemicals, they seem common out there.
That's a crucial point. The gases, the energy sources that likely started life here, they're all over the universe.
So similar chemistry might be happening elsewhere.
Sagan thinks so. Reactions like the ones on early Earth might be making organic molecules in interstellar space, in meteorites. He suggests it must have happened on countless other worlds just in our galaxy.
Okay, but common ingredients don't necessarily mean familiar life forms, right?
Exactly. Look at the staggering diversity just here on Earth, all sharing the same basic molecular biology.
Life elsewhere could be, well, truly alien.
Radically different. Sagan warns against assuming aliens will look like us, even vaguely humanoid. Evolution is this long chain of improbable steps. Life elsewhere, even with similar chemistry, could be utterly unrecognizable.
Good reminder to keep an open mind. Okay, shifting gears. How did we figure all this out? Sagan gets into the history of understanding the cosmos.
Yeah, the big clash. Earth-centered versus sun-centered universe. And Johannes Kepler is central to that story. 16th, 17th century.
A tough time intellectually, right? Religious dogma was strong.
Very restrictive. Dissent could be dangerous. The heavens were seen as, perfect, divine. not governed by physical laws like Earth was.
But Kepler pushed against that.
He did. Born in Germany, initially set for seminary.
Religious training.
But his curiosity about the cosmos just took over. For him, God became less about judgment and more about the creative force behind the universe.
He wanted to understand the mind of God by studying creation itself.
That was his driving force, a lifelong pursuit that really helped shift European thought away from medieval ideas.
And ideas from ancient Greece were starting to resurface then, preserved by Arab scholars.
Exactly. Kepler studied Greek, Latin, math. Euclid's geometry really hit him.
He saw geometry as like co-eternal with God.
Pretty much. Geometry provided God with a model for the creation. Geometry is God himself. He saw cosmic glory in its perfect forms.
Intense passion there, mixing math and mysticism. But the wider world was still pretty superstitious.
Oh, hugely. Famine, plague, war. People felt helpless. Astrology thrived in that climate, looking for answers for control in the stars.
And Kepler's relationship with astrology was complicated.
A bit ambiguous. His science pointed to physical laws, but he still dabbled in astrology, maybe looking for deeper patterns.
But his core belief was that God's creation deserved study, the book of nature.
Right, every part of it. If God made it, it was worth examining.
Then at university, he encountered Copernicus's idea, sun-centered.
A revelation for him. It fit his view of the sun as a metaphor for God. Powerful. He ended up teaching math in Austria, even did horoscopes on the side.
To pay the bills.
Yeah, he justified it saying, God provides for every animal, and for astronomers, he provided astrology.
He sounds brilliant, but maybe not the best teacher.
Apparently terrible. Mumbled, went off on tangents, lost his students completely. Very few came to his lectures.
But it was in one of those confusing lectures that he had his big idea.
The crucial insight, the cosmic mystery.
Right. Tell us about that.
He was obsessed with why there are only 6 known planets. Then Mercury, Venus, Earth, Mars, Jupiter, Saturn. Why 6? Why spaced out like that?
Questions nobody else was really asking.
Exactly. And he knew about the 5 Platonic solids from Greek math, the perfect 3D shapes.
Tetrahedron, cube, those ones?
Right. And he had this amazing idea. Connect the 6 planets and the 5 solids.
How?
He figured the reason for 6 planets was the 5 solids. He imagined them nested inside each other, like Russian dolls.
And that structure determined the planets' orbits, their distances from the sun.
That was his theory. These perfect geometric shapes were the invisible scaffolding of the solar system, God's geometric plan.
Wow, that's incredibly creative. A real leap, but ultimately wrong, Sagan says.
Ultimately incorrect, yes, but it shows how science works. Even brilliant ideas can be wrong. What mattered was his pursuit of mathematical harmony. That drive eventually led him to his correct laws of planetary motion.
Even the wrong turns can lead somewhere important.
Absolutely. He was so convinced he even tried to get funding for a model of it nested solids made of silver and gems.
A jewel-encrusted model of the solar system. That's ambitious.
It got rejected, but they encouraged him to make a paper version first. He poured himself into the math, trying to make it fit Copernicus's data, found immense joy in it.
Incredible dedication. And all this was happening against a backdrop of serious chaos in Europe.
Huge turmoil. The 30 Years' War, witch hunts, paranoia was rampant.
And Kepler's own mother was accused.
Tragically, yes. Arrested for witchcraft. In his own town, women were being tortured, executed. Kepler was tormented, wondering if his own work had somehow contributed.
A stark reminder, even during intellectual breakthroughs, fear and irrationality can be incredibly strong. Okay, let's move to another topic Sagan covers. Comets and collisions. Starts with Tunguska.
Right, the massive explosion in Siberia in 1908. A powerful, real-world example of something hitting us from space.
But no crater.
No crater found. The thinking is it was an airburst, a small comet or asteroid exploding high in the atmosphere.
The eyewitness accounts Sagan shares are chilling. Sky-splitting, intense heat, the blast wave.
Knocking people down miles away. Flattened over 2,000 square kilometers of forest. Just gone.
Terrifying. And Sagan connects this to Humboldt's work.
Alexander von Humboldt, yeah. His popular science book, Cosmos, suggested meteors and comets were linked.
When Darwin read Humboldt, found it inspiring, shows how ideas connect.
It does. And speaking of comets, for most of history, they were just scary. Objects of fear.
Bad omens, right? Predicting disasters, deaths of kings.
Exactly. Their sudden appearance seemed to defy the idea of orderly heavens. Descriptions are wild Babylonian beards, Greek hair, Arab swords.
Even Ptolemy classified them, thought they brought wars.
And theologians got dramatic too. One called a comet the thick smoke of human sins, ignited by God's wrath.
Wow. But Halley's Comet, the records go way back.
Centuries, possibly seen in China over 1000 BC. Maybe the sword over Jerusalem in 66 AD.
The Normans saw it before invading England in 1066 on the Bayeux Tapestry.
Seen as an omen. Giotto painted it as the Star of Bethlehem. Caused panic in 1466. People feared God was siding with the Turks.
So centuries of mystery and fear. Then the scientific revolution kicks in.
Right. Astronomers like Kepler and Newton started looking analytically.
Kepler thought they moved like fish, tails pushed by sunlight.
Yeah. And Newton, even before inventing his telescope, watched them obsessively. His work on gravity showed they orbited the sun like planets, but on different paths.
Elliptical orbits. And that led to Halley's big prediction.
Edmund Halley, Newton's friend. He crunched the numbers for comets seen in 1531, 1607, 1682, realized it was the same comet.
And predicted it would return in 1758.
Bold prediction. Yeah. And it did return. Named after him posthumously, Halley's Comet really made its mark.
Sagan also mentions the idea that comets might have brought water to planets, like Mars.
That's a modern idea, but Newton himself speculated Earth's oceans came from comets. He thought cometary matter was vital for life, a kind of spirit.
And later, scientists found organic molecules in comets.
As early as 1868. And then cyanogen related to cyanide was found in their tails.
Which caused that panic in 1910 when Earth passed through Halley's tail.
Oh yeah, big panic. People thought they'd be gassed. Headlines screamed about free gaseous baths.
Even though the tail is incredibly thin, basically vacuum.
Absolutely negligible danger.
Yeah.
But fear sells. Anti-comet pills, gas masks. Sagan tells a funny story about a drunk guy calling an observatory thinking Comet Aaron Roland was something else entirely.
Shows the range of reactions: fear, science, comedy. No, orbits. Planets versus comets. Very different.
Planets mostly stick to near-circular paths, nicely spaced out. Comets, especially from the outer solar system, have these long, stretched-out elliptical orbits.
Why the difference?
Sagan suggests collisional natural selection. Early on, things with crisscrossing, messy orbits were more likely to smash into each other and be destroyed.
Leaving the survivors in more stable circular orbits. Makes sense.
Yeah.
And where do these comets mostly come from?
The Oort cloud, a vast spherical cloud of trillions of icy bodies way, way out beyond the planets.
Like a giant cosmic freezer.
Exactly. And sometimes a passing star's gravity nudges one, sends it falling towards the inner solar system.
And once they're in here, Jupiter and Saturn can mess with their paths, too.
Yeah, fling them around, change their orbits.
So collisions between planets and comets aren't just possible, they're inevitable over long time scales.
Inevitable, just different frequency. Small impacts like Tunguska happen maybe every 1,000 years on average. Big ones, from Halley-sized comets, are much rarer, maybe once a billion years.
And the big ones leave craters.
Big scars. The moon is the blip's evidence board for that.
Because it has no erosion or atmosphere to wipe the craters away?
Exactly. The ancient highlands are saturated with craters. Even the smoother seas, the Maria, have older craters buried underneath. Studying the moon helps us estimate the impact rate for the whole inner solar system.
And Earth must have been hit just as much, we just don't see the evidence as clearly.
Right. Erosion water, wind, ice plus volcanoes, plate tectonics. They constantly resurface our planet, erase the old scars.
Meteor crater in Arizona is a relatively young one.
Tens of thousands of years old, yeah. There's even that debated story from 1178, monks seeing an explosion on the moon. Maybe a visible impact.
So the moon is shaped mostly by external impacts, Earth by impacts, plus internal geology.
And Mars is somewhere in between. Less geology, thin atmosphere.
Between Mars and Jupiter, the asteroid belt, more cosmic debris.
Like a cosmic junkyard, yeah. Leftovers from planet formation? They collide there too, sending fragments our way.
Meteoroids, which become meteorites if they land.
Tangible pieces of other worlds you can hold in your hand. Amazing.
It truly is. Okay, let's shift focus. Light itself. The electromagnetic spectrum.
Light fundamentally is a wave. It has frequency, energy.
But the spectrum is huge, right? Visible light is just a tiny slice.
Tiny. It goes from gamma rays, super high energy short waves,
Hmm.
all the way down to radio waves, low energy long waves.
And studying light across that whole spectrum is how we learn about the universe, composition of stars, galaxies.
Which makes it funny that Auguste Comte, the philosopher, declared in 1844 that we'd never know what stars are made of.
Famous last words. He couldn't imagine spectroscopy, all the tech we have now.
Shows he can't predict scientific progress. Human ingenuity finds ways.
And this ability to study light lets us explore other worlds. Sagan mentions Pioneer Venus and a diamond.
Yeah, the late 70s Pioneer mission sent probes into Venus's hellish atmosphere. One instrument needed an infrared window.
To see heat radiation.
Right, but it had to survive the heat and pressure and be transparent to infrared, the solution. A 13.5-carat diamond window.
Wow, a diamond sent to Venus. That's dedication.
Incredible engineering.
Now, another world that's always fascinated us, Mars.
Mars has that pull because it seems a bit Earth-like, at least from afar.
Polar caps, clouds, dust storms, seasons, a 24-hour day.
All these things fueled speculation about life there for centuries.
And the early rocket pioneers like Tsiolkovsky Goddard, Mars was often their goal, hoping to find life.
Those dreams became reality with probes and landers, which leads Sagan to a neat thought experiment.
If an alien visited Earth, how would they first spot intelligence?
From far away, maybe not much, but get closer, say 100-meter resolution, you'd start seeing the geometric patterns.
Roads, city grids, farm fields.
Exactly. The large-scale organization that signals technology. Closer still, meter scale, you'd see city lights at night, maybe individual creatures moving.
So it's the large-scale artificial structures, which makes you think of Lowell's canals on Mars.
Percival Lowell's famous illusion. If those had been real planet-wide canals, that would have been stunning evidence.
But decades of spacecraft images show nothing like that.
No global engineering projects. Doesn't rule out life, past or present, but no sign of a big Martian civilization, at least not now.
And the current Martian environment is pretty nasty for life as we know it.
Very harsh, super cold, thin CO2 atmosphere, hardly any oxygen, no ozone shield against UV. Liquid water isn't stable on the surface. Big challenges.
Still, scientists tested if Earth microbes could survive simulated Mars conditions, and Viking landed.
Viking landers in the 70s had experiments specifically looking for life.
The results were ambiguous.
Kind of tantalizing, some weird chemistry, but ultimately no clear, undeniable proof of life at those landing sites.
But Sagan keeps the door open. Maybe life underground. Or life in the past when Mars might have been wetter.
Exactly. The search isn't over. Which brings up the whole debate about returning Martian samples to Earth.
The back contamination risk. Bringing Martian bugs back here.
Huge potential payoff scientifically, but also huge potential risks, however small the probability might seem. Needs incredibly careful handling if we ever do it. Stupefyingly reliable containment, as Sagan puts it.
So for now, robotic rovers are the way to go. Safer and getting more capable.
Increasingly sophisticated. They can travel, analyze rocks, look for clues without the sample return risks. There are robotic pioneers.
Now, Sagan takes this fascinating detour. 17th century Holland. The Dutch Golden Age, what's the link?
It was this amazing period of enlightenment, independence from Spain, and incredible seafaring trade for the Dutch.
They embraced rational thought, innovation, and their survival depended on ships and global trade.
Right. The Dutch East India Company was this powerhouse, sending ships everywhere for spices, textiles.
Long, dangerous voyages. Lifeblood of the Republic.
And navigational charts were top-secret state assets. Ships often sailed under sealed orders. They left their mark everywhere. Barents Sea, Tasmania.
So it wasn't just about money. There was a spirit of discovery, too.
Definitely. Exploration, encountering new lands, cultures, plants, animals. It went hand in hand with trade. Their Amsterdam town hall reflects that confidence globes, justice trampling avarice.
And that huge world map inlaid on the floor where they modestly left Holland off.
Yeah, just use the old Latin name Belgium for the region. Shows their global reach, but also a certain restraint. They were sailing to Indonesia, Australia, New Holland, China, encountering the world.
It's a great parallel. A society pushing boundaries, exploring just like we look to the cosmos now. Okay, back to light. Newton thought particles. Huygens thought waves.
That was the big debate. Newton liked particles because shadows are sharp. Huygens' wave theory explained things like diffraction better.
And waves won out for a while.
For a long time, yes. But then Einstein, 1905, the photoelectric effect, showed light also acts like particles, packets of energy, photons.
So it's both. Wave-particle duality, quantum mechanics, weird stuff.
Fundamental weirdness. And Huygens, the wave guy, he was brilliant beyond optics, too.
Right, pendulum clock. Huge deal for timekeeping, navigation.
Mechanics, probability theory, better air pumps, the magic lantern early projector, even tried a gunpowder engine. A real polymath.
And he lived during that Dutch Golden Age, saw Copernicus's sun-centered view becoming accepted there.
He loved that. Found it amusing only the slow-witted or authority clingers still resisted it.
And that shift, sun-centered, it really opened things up philosophically about other worlds.
Big time. Before, the heavens rotating around Earth seemed to argue against other worlds. But if Earth rotates,
Yeah.
maybe it's just a planet.
And other stars could have planets too.
Giordano Bruno was maybe the first to really push that infinite suns, infinite worlds. Radical idea then. Met resistance.
Always resistance to big new ideas, it seems. Okay, the Voyager logs Sagan includes. What do they show us?
They're these short, compelling snapshots of deep space exploration. The reality of it.
It's
Worries about instruments right after launch. Deploying the science boom. That first amazing Earth-Moon photo.
trajectory corrections, the main radio failing, needing the backup.
Scary moment. Crossing the asteroid belt, Jupiter's radiation, losing lock on the guide star Canopus temporarily.
It really highlights the challenges, the fragility, the skill involved.
The dedication, the problem-solving needed millions of miles from home. It brings the human element out.
And Sagan then shares how his own cosmic fascination started, a library visit.
A key moment. He asked for a book on stars, got celebrity photos first. Funny misunderstanding.
But then he got the right book, and learned stars are distant suns.
Blew his young mind. The scale of it all. Overwhelming.
And the next logical step for him was, if they're suns, they could have planets.
And some of those planets could have life. That childhood reasoning set him on the path to become an astronomer.
And he felt lucky his parents and teachers encouraged that ambition.
He reflects on living in the first era where we can actually explore other worlds, unlike all of history before us.
He sees it as a culmination of ages of human curiosity.
And he talks about how kids sort of retrace our ancestors' thinking. Gazing at the sky before we had science and libraries.
Imagining the discovery of fire, early beliefs about stars.
Right. When our ancestors were just as smart, just as curious, but lacked our accumulated knowledge.
Which leads him to how ancient cultures revered fire almost like a living thing.
Tied to the hearth, to family, ancestors. The eternal flame tradition comes from that deep connection.
Then he moves to early scientific inquiry, Empedocles and air.
Empedocles, around 450 BC, physician, philosopher, did one of the first recorded experiments.
The clepsydra, the water thief.
Used it to show invisible air is real stuff, takes up space, exerts pressure, moving beyond just thinking to testing.
And he had other cool ideas. Light travels fast, but not instantly. Hints of natural selection.
Remarkably insightful for his time, though the story of him jumping into Mount Etna is probably just a story.
Adds drama, though. Then Democritus, atoms.
Democritus of Abdera developed a much fuller atomic theory, coined the word atom, meaning uncuttable.
His idea. Nothing exists but atoms in the void.
Right. He argued if you can cut an apple, there must be empty space void between the atoms.
And he even touched on ideas leading to calculus, thinking about a cone as stacked plates.
Amazing foresight, trying to calculate volume by infinite divisions. Such a tragedy, most of his writings are lost.
Makes you wonder what else he figured out. Okay, Pythagoras, the theorem.
The Pythagorean school, yeah. Famous for the theorem, but more importantly for developing mathematical proof. Logical deduction.
And he used the word cosmos for an ordered universe knowable through math.
Contrasting with the Ionians, who focus more on observation, Pythagoras seemed to think pure thought could unlock it all.
And they were kind of mystical, too. Weird beliefs.
Definitely. Transmigration of souls, not eating beans, form a sort of religious order, even got political.
But relied heavily on the master said so, authority over argument.
Cicero criticized that later. Argument should stand on its own logic.
And they loved those regular solids, the Platonic solids.
Fascinated by them. Attributed mystical meanings cube is earth, etc. But the dodecahedron, with pentagon faces, made them uneasy.
And discovering irrational numbers like the square root of 2, that really shook them.
Hugely. It couldn't be expressed as a simple ratio of whole numbers. Challenged their whole worldview that everything was whole numbers and ratios.
So they suppressed it, kept it secret.
Apparently so. A cautionary tale about resisting ideas that challenge your core beliefs, even for brilliant people.
Sagan draws a parallel to modern scientists maybe being reluctant to share complex ideas too widely.
Wanting to keep some knowledge sacred within the group. It leads him to why Ionian science eventually declined.
What were the reasons?
A mix of things. The slave economy may be devalued practical application, political turmoil, rise of more mystical philosophies.
Science flourished for a while in Alexandria at the library.
But similar issues, slavery, entrenched elites, might have held back sustained science in other ancient cultures too. India, Mayans, Aztecs.
And even Plato and Aristotle, their ideas, while influential, had downsides for science. Accepting slavery, separating earth and heavens.
Yeah, their hierarchical view of the cosmos, earth flawed, heavens perfect. That mindset rejected Aristarchus's early sun-centered model.
And Plato supposedly wanted Democritus's books burned, and most Ionian writings are lost.
Tragic loss. While Plato and Pythagoras saw the universe as knowable, mathematical, which was huge, their elitism, mysticism, suppressing facts, those were setbacks.
But the Ionian approach, observation and experiment, it came back eventually.
After the long, mystical sleep, yeah. Rediscovered books sparked the Renaissance, scientific revolution, though some old biases still linger.
Like the idea of Earth being special, leading to rejecting Aristarchus, whose writings are also lost.
Frustrating gaps. Even later, Wallace, co-discoverer of natural selection, argued Earth might be uniquely inhabited.
Took 20th century discoveries to really place us. Shapley showing we're in the galactic suburbs, not the center.
Right. Herschel had misjudged because of dust blocking the view. We're out in the sparse regions.
Imagine the view near the galactic core. Millions of stars.
Breathtaking. Then, Hubble, in the 1920s, proved Andromeda wasn't just gas, but a whole other galaxy. An island universe.
Opening the floodgates to understanding there are billions, maybe trillions of galaxies.
It's this ongoing story, Sagan says, of finding our place, consistently moving from the center stage to, well, a less significant spot in the cosmic drama.
Humbling discoveries, mostly very recent. And while some resist, Sagan argues understanding the cosmos is vital for fixing our own neighborhood.
We make our planet significant, he says, through the courage of our questions and the depth of our answers.
Powerful thought. Now he shifts to the improbability of us as individuals.
The sheer odds against any specific sperm fertilizing an egg. Tiny factors determine it. We are incredibly contingent beings.
If history had zigged instead of zagged 2,500 years ago, none of us would be here. Different people entirely.
And he wonders, what if that Ionian scientific spirit hadn't faded? What if it continued?
He imagines us exploring nearby stars by now, Greek as the language of science, the dodecahedron as a symbol.
A fascinating what if. Our actual progress is slower, but he's still optimistic about future interstellar travel.
It reminds us planetary systems are common. Jupiter, Saturn, Uranus have their own mini-solar systems of moons.
And he explains how we detect exoplanets now looking for the wobble they cause in their star's motion. Barnard's star was an early target.
And other methods are developing too, like seeing the star dim when a planet passes in front.
Occultation, yeah. The search for other worlds, other life is really ramping up.
Okay, from exoplanets to black holes. Some of the strangest things out there.
Objects so dense, gravity so strong, not even light escapes once it crosses the event horizon.
The idea was around early, but mostly ignored, until X-ray astronomy took off.
Right. Earth's atmosphere blocks X-rays, so we needed space telescopes. Uhuru was key.
It found Cygnus X1, a bright, flickering X-ray source.
In 1971, the rapid flickering meant it had to be small, light travel time limit size.
And optically, there's a big blue star there, orbiting. Something invisible.
Invisible, but massive. About 10 times the sun's mass, calculated from the blue star's orbit.
Too massive and small to be a normal star or even a neutron star.
Leaving a black hole is the only explanation. The X-rays come from gas ripped off the blue star, superheated as it spirals in.
So Cygnus X1 was really strong evidence, and others have been found since.
Several candidates, Sagan lists V861 Scorpii, SS433, maybe one in Cassiopeia, a supernova remnant. X-ray telescopes are crucial.
And he explains black holes using Einstein's idea of gravity as curved spacetime, the rubber sheet analogy.
Yeah, helpful way to visualize it. Mass warps the fabric of space. A heavy ball makes a dip.
And a black hole is like an infinitely deep well in that fabric.
A bottomless pit in the analogy. He also mentions the weird time effects, time slowing down near the horizon, and speculates about wormholes and rotating black holes. Theoretical shortcuts through spacetime.
Mind-bending. Okay, from the superdense to the supervast, the Big Bang. Sagan contrasts ancient myths with the science.
Ovid's Milky Way myth, the Janasena's idea of an uncreated world, then the Big Bang Theory, the start of our universe, 10, 20 billion years ago.
The why it banged is still a mystery.
A huge mystery. But the evidence it did happen is strong. Early universe. Incredibly hot, dense, radiation, basic particles.
Hydrogen and helium, mostly.
As it expanded and cooled, gravity pulled stuff together. Tiny unevenness grew into gas clouds.
Yeah.
The seeds of galaxies.
And as the clouds collapsed, they spun faster. Conservation of angular momentum.
Like a skater pulling their arms in. That spin determined if they became flat spirals like ours or rounder ellipticals.
Same physics everywhere, so similar galaxy types everywhere.
Right. And within galaxies, smaller clouds collapsed to form the first stars, igniting nuclear fusion.
And when those first massive stars died, supernovae.
Huge explosions. They created heavier elements, carbon, oxygen, iron, everything needed for planets and life, and scattered them.
And the shockwaves triggered more star formation.
A continuous cycle. Hierarchical condensation. Big Bang, galaxies, stars, planets, life, intelligence.
Yeah.
Here at least.
And galaxies cluster together, too. We're in the local group.
Relatively small. Others are in huge clusters, thousands of galaxies, all interacting, colliding, merging over billions of years. Galaxies aren't solid, they're fluid.
Some have active cores, super bright centers.
Active galactic nuclei, often powered by supermassive black holes.
Sagan also mentions ancient ideas of cosmic cycles, oscillating universe.
Yeah, the idea the universe might expand, then contract in a big crunch, then maybe rebound in another big bang. Endless cycles.
And notes that ancient Maya and Indian cultures had concepts of vast timescales, billions of years, long before Europe did.
Remarkable foresight. He also floats transphysics, maybe deeper laws governing our physics.
So how do we figure out the universe's fate? Expand forever or collapse?
Two main ways. Count up all the matter and energy to see if gravity is strong enough to stop expansion.
Or look really far away, which is looking back in time, to see how expansion has changed.
Radio telescopes like the VLA are key for seeing faint, distant objects. Future arrays could be even bigger, continental scale, solar system scale.
Needed because the distant stuff is incredibly faint.
And these telescopes also map things that don't emit visible light, like gas and dust clouds. And they search for alien signals, of course.
There's that X-ray glow between galaxies, too. Still debating what causes it.
Hot gas or maybe loads of distant quasars. Need observations across the whole spectrum to figure these things out.
Requires diverse tools, diverse approaches. Okay, let's turn inward again. The human brain, the most complex thing we know.
Sagan calls it that. Introduces the triune brain idea, evolutionary layers. Brainstem for basics.
Our complex, the reptilian brain for aggression, ritual.
Limbic system for emotions, memory. The mammalian brain.
And the cerebral cortex on top. Consciousness, thought, language, math, music. That's us.
Where matter is transformed into consciousness, its language is in DNA, its electrochemical signals between billions of neurons, trillions of connections.
He quotes Sherrington, the brain lighting up on waking, an electrical storm.
Even asleep, it's busy dreaming, consolidating memories. Thoughts are physical events, electrochemical impulses.
And the cortex is all folded up to maximize surface area.
Huge area packed into the skull, incredible complexity in the chemistry, the circuitry. But no evidence, Sagan says, of function beyond those connections. No magic stuff.
And the two hemispheres. Right for patterns, intuition, left for analysis, language.
Roughly, yeah. But they talk constantly via the corpus callosum. It's a partnership.
The information capacity is insane. Trillions of bits, like 20 million books in your head.
A much bigger library than our genetic code. Highlights why our passion for learning is so important.
We're not just dictated by genes. The cortex frees us, but makes us responsible for what we learn, what we believe.
He uses the analogy of cities growing haphazardly, old parts next to new, like the brain's evolution. Older, basement functions still there alongside higher thought.
It can recall, but also compare, synthesize, abstract, amazing capabilities. But no telepathy.
No evidence for it. We communicate through art, writing, speech.
Which leads naturally to, are we alone, SETI?
He starts with an Eskimo myth, a Vedic hymn, then the Drake equation. Frank Drake's attempt to estimate communicating civilizations in the galaxy.
Breaking it down into factors. Star formation rate, fraction with planets, habitable planets per system.
Fraction where life arises, fraction with intelligence, fraction developing technology. And the big one.
L, the lifetime of a technological civilization.
That's the killer variable. Do civilizations survive their technological adolescence? Or do they self-destruct? Nuclear war, climate collapse.
If even 1% make it through, there could still be millions out there.
That's the calculation. The biggest uncertainty, Sagan says, is basically human nature, economics, politics, our tendency towards conflict.
But if self-destruction isn't inevitable, maybe the sky is softly humming with messages.
Beautiful phrase. Receiving a message would be profoundly hopeful. Proof that survival is possible.
If they're out there, nearest might be 200 light years away. Ish.
Rough estimate. Which is why, Sagan argues, it makes sense for us to listen right now, not shout. We're beginners at radio astronomy. They're likely far ahead.
And we've only just started looking tiny fraction of stars checked.
But a serious search is underway. Relatively cheap. Cost of a naval destroyer for a decade's program.
And first contact likely won't be like the movies. No ships landing. More likely, a signal.
A light touch across interstellar space.
Yeah.
Very different from historical first contacts on Earth, which were often messy.
He uses examples like La Perouse in Alaska with the Klingit. Initially wary, but okay, then some friction.
And contrast that with Cortés and the Aztecs. Sophisticated culture met with utter destruction.
Makes you wonder about contact with advanced ET, peaceful exchange, or...
Unpredictable. He briefly mentions reasons aliens might travel escaping supernovae, maybe nomadic, but thinks them actually arriving here is highly unlikely.
Which brings us back to the most immediate threat. Us. Nuclear self-destruction.
The power is terrifying. Hiroshima bomb equaled WWII's destruction. Today's arsenals are vastly greater, aimed at thousands of targets during the Cold War.
Immediate effects. Blast, firestorm, radiation. He includes a Hiroshima survivor's account. Harrowing.
And Hiroshima was an airburst, less fallout. Bikini Test fallout was much worse, hit the Rongelap people hard. Thyroid issues, tumors.
And today's weapons are millions of Hiroshima equivalents, potentially. Billions could die.
Plus long-term fallout, strontium-90, cesium-137,
Right.
stays dangerous for decades, and ozone depletion from high-altitude blasts, more UV radiation.
Damaging crops, ecosystems, causing cancer, a truly global catastrophe.
Chilling stuff. But Sagan doesn't end on despair. He finds hope.
Mentions Prescott's work linking child-rearing practices to adult aggression. Nurturing kids could lead to a more peaceful future.
An interesting idea. And he points to real positive changes. Abolition of slavery, rising equality for women, less tolerance for aggressive war, better treatment of children.
Signs of a new consciousness emerging, recognizing our unity.
He hopes so. Quotes Theophrastus. Superstition is cowardice in the face of the divine.
Yeah.
Celebrates what science has revealed: atoms and stars, new suns, life spark, galaxies, quasars, black holes, maybe alien life.
Contrast that richness with the paleness of pseudoscience. Urges us to embrace science, understand it. It's human.
Finds mystery and wonder everywhere in nature. Says those who fear the universe prefer superstition. The courageous explore.
Science is our invention, evolved because it works. And its rules.
2 core rules.
Yeah.
No sacred truths, question everything, authority means nothing. And second, if it doesn't fit the facts, revise or discard it.
The essence of the scientific method. Okay, near the end, he revisits Alexandria, the library, Hypatia.
Mentions Archimedes inventing the water screw there, but thinking practical stuff was beneath science. Then Hypatia.
Last great scientist of the library. Mathematician, astronomer, physicist, philosopher.
Lived as classical civilization declined under Rome, Christianity rising, suppressing pagan learning, science.
An extraordinary woman in male domains. Respected, but also a target.
Cyril, the archbishop, saw her influence, her link to pagan science, as a threat.
Leading to her horrific death by a mob of his followers, flayed alive, burned.
And Cyril became a saint. The library's destruction followed soon after. A self-inflicted brain surgery on civilization, Sagan calls it.
The loss of knowledge. Unimaginable. We only have fragments of what was there.
Tantalizing titles of lost books, like only having a few plays by Sophocles. So much gone.
Finally, Sagan uses math proofs to show insights into reality, irrational numbers.
The Pythagorean proof that root 2 can't be a simple fraction. Uses reductio ad absurdum, assume it is a fraction, show it leads to contradiction.
Elegant, unexpected. And the Pythagoreans tried to hide it.
Then Euler's formula for polyhedra. VE plus F equals 2. Vertices minus edges plus faces equals 2.
Works for a cube. 8 vertices, 12 edges, plus 6 faces equals 2.
And using that, plus relationships between faces, edges, vertices, you can prove there are only 5 regular solids.
The Platonic solids again. The math reveals fundamental limits on geometric shapes in our space.
Deep truths accessible through reason and proof.
So wrapping up this huge journey through Cosmos, we've covered vast space and time, life's origins, our struggle to understand, the thrill of discovery.
And the crucial role of science in figuring out our place in it all, the power of knowledge is immense.
And the potential for more exploration seems boundless.
Absolutely.
Yeah.
Which leaves you, the listener, with a final thought, perhaps.
Considering these vast scales, cosmic events, what does it really mean to be significant?
How does our ability to understand, our curiosity, our science, how does that shape our significance in this immense universe?
Something to ponder. Maybe even dip back into Sagan's Cosmos yourself for more insights.